Electrical resistance is a force that opposes the flow of current in a circuit. In order to overcome the resistance and allow current to flow, a potential difference or voltage is applied. Resistance is measured in ohms, and it can be calculated using Ohm's law. Resistance equals voltage over current. There are four main factors that influence the resistance of a conductor: the cross-sectional area, the length, the material it is made from, and the temperature. Let's take a closer look at these. Increasing the cross-sectional area of a conductor causes a decrease in resistance. We can see here two wires, the second with a larger cross-sectional area than the first. This means the resistance of the first will be larger than the resistance of the second. Next, it is important to note that an increase in length causes an increase in resistance. Here we have two wires, the second longer than the first. This means the resistance of the first is smaller than the resistance of the second. The material from which the component is made will also influence its resistance. If it is made from a conductor, it will have a lower resistance than if it were to be made from an insulator. Finally, we can consider the effect of temperature. If we have a conductor, an increase in temperature leads to an increase in resistance. With insulators, increasing temperature causes a decrease in resistance. We also have a special case, superconductors. In a superconductor, extremely low temperatures can cause there to be no measurable resistance at all. Combining these factors, we find that resistance is equal to the resistivity of the material multiplied by the length over the cross-sectional area. If there has been a change in temperature, this is also multiplied by 1 plus the temperature coefficient of the material multiplied by the change in temperature from 20 degrees Celsius. If we happen to know the power within a circuit and also the current or the voltage, it is possible to calculate the resistance simply by rearranging one of the power formulas. Resistors are small devices used in electrical circuits in order to establish a specific resistance between 2 points. They have a nominal resistance value and a tolerance on this value, which are both indicated through combinations of coloured bands on the component. Resistors also have a power rating, which is the maximum amount of power that it can handle before being damaged. When resistors are connected in series, their values sum up to provide a larger total resistance. When connected in parallel, however, their values sum to provide a lower total resistance than the lowest individual resistor value. Finally, we'll look at notation. In a DC circuit, resistance is denoted as a scalar quantity, meaning it has magnitude only, while in an AC circuit it is considered a vector quantity, meaning it has magnitude and angle. You'll look at this in more detail later.